Okay, so for today's notes on quadratic applications, this is 7.7. We've been given for number 1 a rectangle here, and it says that the length of the rectangle is 3 more than twice the width. Okay, so we can actually translate this into an equation, here. The length, so the length L is. So anytime we see is, that is our equal sign. So L equals. So I'm going to write it over here. Length equals, so that is 3 more than twice the width. So L equals 3 plus 2W. Okay? Now I know that for my rectangle, the width is just simply the width. It's not saying anything about it. So for A, it says write the function of the area in terms of the width. Well, we know that area is length times width, but instead of using L, I'm going to use 3 plus 2W, okay, because that's what L equals. So I'm going to rewrite that as area equals 3 plus 2W, so that's my length, times the width. Now, I can even simplify this a little more. I can go ahead and get rid of the parentheses here by taking this W and distributing it. We can actually distribute in this way too. It doesn't matter. So we're just multiplying W times 2W and then W times 3. So my final area, which I'm going to write below here, okay, my final area is, okay, so we got W times 2W. That would be 2W squared. And then W times 3. So that would be plus 3W. So notice, ladies and gentlemen, that our area is a quadratic function. Area equals 2W squared plus 3W. So for B, if the area of the rectangle is 27 centimeters squared, find the dimensions. So right now this is saying that area, A, the area is 27. So I'm just going to replace this by 27. Okay? So writing that over here then, which here, so, oops, that's not what I wanted. 27 equals 2W squared plus 3W. Okay? So I'm just going to go ahead and solve this. Now, usually what we want to do is get everything on one side. So my first move would be to minus 27 to the other side. Okay? So what we have here now is 0 equals, yucky equal sign, 0 equals 2W squared plus 3W minus 27. So in this case, this looks more familiar to us. This is a regular quadratic trinomial, and it is set equal to 0. So now let's go ahead and solve this using any method that we've learned. Now the methods that we've learned so far are factoring, complete the square, or the quadratic formula. I would say factoring is the easiest method here. So let's go ahead and see if we can break this up into 2 binomials. Okay, so since this is 2W squared, we must have 2W times W. Okay, that's the only way we can get 2W squared. I look at my signs. Okay, this last sign's a minus, so therefore they're going to be different. So one's a plus, one's a minus. And I'm looking for multiples of 27 that combine to positive 3. So 27, that would be 9 times 3. Okay, and I need to figure out which order would I have. What order do I need to put it in to get positive 3W? Well, in this case, we need to figure it out. So 9 and 3 is actually going to be the order that we want. Plus 9 minus 3, okay? You can always check yourself, okay? If you multiply the two insides here, 9 times W is 9W. And then the outsides, 2W times negative 3, that would be negative 6W. So 9W minus 6W would give you positive 3. So that's your quick check. All right, so we factored it, but now we need the actual two solutions. So we would have 2W plus 9 equals 0. And for this one, W minus 3 equals 0, we know is just W equals 3. Okay, So I have this solution for the other solution, here, for 2w plus 9. We have to minus 9 to the other side, and then we have to divide by 2. So I'm just going to go ahead and put our answer here. We would end up with, over here to the side here, so w equals negative 9 divided by 2, so that would be negative 9 over 2, okay, which is also negative 4.5, okay? All right, so basically what we've done is we have solved this quadratic, and of course this quadratic had two solutions, w equals 3, w equals negative 4.5. But in terms of this situation, okay, it does not make sense to have two different values for the width. So one of them we can cross off. And the one that we're going to cross off is w equaling negative 4.5. It just doesn't make sense to have a negative width. It's like having negative money. We don't talk about having negative $5. So that width is taken off. Therefore, we only have one true width, and that is w equaling 3. So we have just found out the width. Okay, w equals 3. And if the area is 27, the length must be 9. So that took care of that one. Now the last thing we need to do for this problem is C, okay? C, where it says find the perimeter of P. Okay, well we know perimeter means you just add up all the sides. So if I've been given my triangle, or my rectangle, I have my length now is 9, 9. My width, my width is 3. So perimeter means you just add up all the sides. So P is going to equal 9 plus 9 plus 3 plus 3. So after adding those up, you end up with 24. So P equals 24 centimeters. And there you go. So we took care of number 1. Okay, quadratic applications. Number 2 is very, very similar to number 1. The only thing I'm going to do for number 2 is just set it up. And that's looking here at the top here. The length of the rectangle is 4 feet less than. Okay, so this is tricky. Okay, be careful when you write this as the length. Okay, this is saying that the length is, okay, 4 feet less than 3 times the width. That looks like this. Okay, this is saying that this is 4 feet less than 3 times the width. You have to be careful. Whenever you see that less than, it's actually flipped. Okay, so the length is this. So you would go ahead and set up the area of this rectangle as the length times the width. Now I'm going to go ahead and just put the w first, the width times the length. Well, the length is 3w minus 4. And so finally, we would get area equals 3w squared minus 4w. And then you would go ahead and continue solving, okay? All right. This one we did not have. This is not on the notes, so don't worry about that one. Okay, so for the next question, we have a soccer player waits 2 seconds before kicking the ball into the air. If the ball reaches its maximum height at 5 seconds, then when will it hit the ground? Well, we can go ahead and visually see what's going on here. Here we have the x-axis, which is going to represent time. And then we have the y-axis, which represents height. Okay? So if the soccer player is waiting 2 seconds before kicking the ball up into the air, the ball doesn't start going up until right here at 2 seconds. And it reaches its maximum height at 5 seconds. So that means that 3 seconds later, because it's already been 2 seconds, so then that's That's 3, 4, 5. At 5 seconds, it's reached its maximum height. So right now, the maximum height here, okay, represents the vertex. Okay, the max height represents the vertex. So when will the ball hit the ground? Well, we know it's going to hit the ground eventually. Okay, let's use the axis of symmetry to help us out here. The axis of symmetry, if I count to the left 1, 2, 3 points, that's where we hit the ground over here. So therefore, 1, 2, 3 points later. So 1, 2, 3 seconds later, it will hit the ground, and that is at 8 seconds. Okay, and then the next section, this is technically on the next page, we have the vertical motion formula. Okay, so we've been given a formula here that, we've been given a formula that has h equals negative 8t squared plus vt plus s. H represents the height of the object, t represents time in seconds, v represents the initial upward velocity, and s represents the initial height. Okay, notice with quadratics, all sorts of problems can be used as quadratic equations, mainly gravity. So anything that goes up and then comes back down due to gravity, that is a parabola. That's a quadratic equation. So this formula represents anything being shot up in the air. So notice for number 1, an arrow is shot up into the air. Therefore, we can use this equation. Okay? So we have an initial upward velocity of 57 feet per second. So this says that v equals 57. Okay? And it says an initial height of 5 feet. So S equals 5. So therefore, we can write this equation, okay? H equals negative 8t squared plus VT. So V is 57. And then plus S, so plus 5. And there you go. There's your equation. We're mainly used to, we don't really work with h and t. We usually work with y and x. So this equation is the exact same. Okay? Y and x, h and t, it all works. So this page, we are mainly using the calculator to help us. Okay? And I'm just going to mention just a few things. For B, calculate the height after 2.7 seconds. What about 5.1 seconds? So this is marking that t. Okay, we want to plug 2.7 in for the t. Okay, so you would go ahead and just plug 2.7 in for this t here and in for that t. I would recommend just using the calculator. Okay, just plug it in in the calculator section and see what you get. Okay, same thing for 5.1. The rest of the questions, we will use the calculator. C says, when will it reach its maximum height? Well, maximum height represents the vertex. So you could just plug this equation in and find the vertex. Okay? D, what is the maximum height? So again, this question is asking about the vertex. And the last question, when will the arrow hit the ground? So again, you can just use your calculator and figure out when it hits the ground. So this page is mainly calculator use.